Welcome to another video. We have a problem from the Harvard MIT Math Tournament of 2013, and this was from the guts section. Based on my experience, I think the problems you see in the guts section are based on what you think or just your guts. Maybe that's why it's named that way, or your experience, because it doesn't matter how smart you are, this is going to throw you off. This number is too big. How am I supposed to know what divides it and how many times it does it and how many times am I supposed to divide the number before I get all the prime factors? So you're not expected to actually use that strategy. That's why it was on a competition like this. So you're going to ask yourself, what is the key? Well, the key is that I am back. It wasn't a break that I chose, but I had to take a break from making videos because I had to take care of some other things. But I'm glad to be back now, and thank you for supporting this channel. If at the end of the video, this video makes sense, make sure you like the video at the end, not now, okay, just wait. If you like it at the end, and leave a comment in the comment section, and hit the subscribe button if you're not subscribed. And share with your friends and family and those that you know are your enemies also, because they might need it. Okay, and let's get into the video. So precisely what strategy is expected here. You have to look at the number. And like I said, this question is based on experience, okay? One thing you will notice is that whenever you write a number and you see that it ends the same way or in a similar way or the reverse way of how it starts, the number 11 should be showing up in your imagination, okay? Because if you multiply 11 by any number, it tends to repeat stuff. If it doesn't repeat stuff, then it tends to mirror things, okay? Like 121 is more like you're coming from both sides and everything is 1 on either side. As you can see, I see 1 here, I see 1 here, but I see zeros, I see zeros. So the number I'm talking about is not necessarily 11. It must contain 2 zeros between the ones. That's something that you learn by experience. So if you take a number and you raise it to a power, what happens is if the number begins with 1, has a bunch of zeros and then ends in 1, it's going to give you some picture of the Pascal's triangle. That's just how it is. Look, 111 squared is 121. 121 is the second level of Pascal's triangle. Let's look at this. Consider 1 squared, it's 121. This is Pascal's triangle. Let's do it. It's 1, 1, then you have 1, 2, 1, then you have 1, 3, 3, 1. If you raise 11 to the third power, what do you think you're going to get? You're going to get this. 11 to the fourth power is going to give you 1, 4, 6, 4, 1. Instead of 11, if we take 101, and you square it, our answer is going to be 10201. Now, see what you see, that this 0 is here because we have a 0 between the ones, and there's a 0 before the last one. So you can easily suspect that whatever we have here must have 2 zeros. Now, let's raise this to the third power and see what happens. What about 101 to the third power? Is it going to give us the third level of the Pascal's triangle? Because if we get that, then we can predict what this number is. Okay, so what about 101 cubed? Well, it should give us, 101 cubed, it should give us 1, 0, starting. At the end, we should get 0, 1. Because it is cubed, then we must have 2 3s in the middle. We just don't know how many zeros are going to be between this and this and this. But because this has only one zero, I believe it's just one zero. How many zeros are here? We don't know. How many zeros are here? Well, it has to be at least, we're going to get one. But this one appears to mirror this one. So let me see if there's going to be one zero here or two zeros or a different number. There can't be a different number because it has to give us the third level of Pascal's triangle. Okay, this is all you get when you raise this to the third power. So now with experience, looking at this number, if you ignore all the zeros, what level of Pascal's triangle are we dealing with, and what number did we raise to the power? Well, because it ends in 001 and it starts in 100, it must be the number 1001. So that it goes this way and it goes this way. And what level was it raised to? Well, Pascal's triangle has betrayed itself here because 7 is the very first one, which is the level we're going to get to. If we keep going, this is 1, 5, 10, 10, 5, 1. Or you go again, 1, 6, 15, 20, 15, 6, 1. So you just keep adding, and this is 1, 7, 21, 35, 35, 21, 7, 1. This is the set of numbers we're going to get if we ignore all the zeros in the number. And that is the secret to solving this problem. So just to clarify, just to give you more clarification, I decided to write this out. 1 squared is 121, no zeros involved. But once I put a 0, it's just like this, but you now have zeros showing up after 1 and before 1. If you do it 3 times, it shows up before and after, and you have the same 3 to show that it is the third level of Pascal's triangle. If you go here, this is what I'm anticipating, that the very first, I've not done it on the calculator, but let's see. It's going to be 1, 0, 0, and it's going to end in 0, 0, 1. In the middle, we're going to have, because this is the second level, a 2. Check that and see if that's correct. It is correct. So you can guarantee that what we have here will be correct. So let's solve. Ignoring the zeros, we get, what do we get? We get 1, 7, 21, 35, 35, 21, 7, 1. And this is the 7th level of Pascal's triangle, and we can claim that the number that was raised to the 7th power was 1001. It is true. Okay? Therefore, the number is 1001 raised to the 7th power. That is the number that gives us this. But we're not done. The question didn't say, hey, tell us the short form. We want the prime factorization. So what are the factors of 1001? Is 1001 a prime number in itself? Because if it's a prime number, then this is our answer. But it's not. So when you're dealing with prime numbers, it is very wise of you to deal with the prime numbers that are bigger than 5. So you want to start knowing the product of 7, 11, 13, 17, 19, 23 if you go for competitions, because those numbers might just show up again. And this is a special number because it is the first number you're going to be getting once you go past 5 and you multiply consecutive prime numbers. So 1001 is well known in the world of mathematics, especially those who do prime numbers or who do competitions, that 1001 is equal to 7 times 11 times 13. This is known. Therefore, we can say that the prime factorization is 7 times 11 times 13 raised to power 7, which is the same thing as 7 to the 7 times 11 to the 7 times 13 to the 7. And this is what we're looking for. Never stop learning. Those who stop learning, stop living. Bye-bye.